Honors Geometry, Unit 4, Day 3 notes. Last notes of semester number 1. Here we go. We're going to start with a topic that just incorporates proofs that we did in Unit 3 and just takes it maybe a step or two further and incorporates parallelograms into those proofs. We did triangles in Unit 3, so let's take a peek at filling in some blanks for a proof that involves parallelograms. Okay, so start right off. The given information is that QRST is a parallelogram. So we know a lot of things about parallelograms. Since it's given that the parallelogram is there, let's use those things. So because of the definition of a parallelogram, which is that two sets of opposite sides are parallel, we can say that QR is parallel to, well, QR must be parallel to segment ST. So segment ST is what would go there. And then QT must be parallel to RS, segment RS, because that is the definition of a parallelogram. So now that we've gotten parallel lines, we can start using our Unit 2 material, parallel lines crossed by transversal. And in this case, we're going to be using alternate interior angles a couple of times. So let's look at it. Angle 1 would be congruent to angle 4 because they are alternate interior angles. Okay. And then we can look at angle 2 must be congruent to angle 3. Because again, alternate interior angles are congruent. So they're trying to prove those two triangles are congruent right now, just like we did in Unit 3. All right, I'm going to take the, the parallel markings off. You don't have to. I just like to keep the markings limited to only congruent markings. All right, so that's what we have. All right, next up, blank is congruent to blank. Well, if you remember in your proofs, after we got everything from the given, and in this case, they got the given being that two pairs of opposite sides are parallel, because that's what the definition of parallelogram is. And we got all the angles that were congruent from there. Next thing is the picture. Well, the picture has a common side. So I can say that that side is congruent to itself. So that segment RT is congruent to itself, segment RT. And you remember that the reason that something is always congruent to itself is the reflexive property. Okay, all right. So now we've got enough markings here. 3 markings in the left triangle, 3 markings in the right triangle. We can say triangle QRT is congruent to triangle blank, blank, blank. Make sure that it's in the right order. So Q is the first letter. Corresponding with Q in the first triangle would be S in the second triangle. And then R, well, corresponding with R in the first triangle. In the first triangle, it's angle 1. That's where angle R is. Remember, angle 1 was congruent to angle 4, and angle 4 has a vertex point T. So the T would correspond to the R in the first triangle. And then the T in the first triangle has angle 3 there, and angle 3 was congruent to angle 2, and angle 2 had a vertex of R. So QRT is congruent to STR. And you look at your markings, we have an angle, and we have an angle, and we have the included side between those two angles. Okay, so because we have the included side, that is ASA, the angle side angle congruence postulate. Then finally, once we have once we have the triangle congruence statement, now we can take the corresponding parts. So it says QR, first two letters, is congruent to ST. Yep. And also QT, first and third letter, congruent to RS, which is again the first and third letter. Those are line segments, so the order that I mentioned the segments should not matter. Those are all corresponding parts of congruent triangles, and they are congruent. Okay, so that is completing the proof. Let's look at your next question. All right, so it says to plot these 4 points, which I just did, and we can connect the dots here if we'd like. All right, it's actually not bad. So it's asking you, choose the best description of the polygon from the choices. Is it a triangle? No, it's not a triangle. A triangle has 3 sides to that polygon. Is it a rectangle? Well, remember, a rectangle has a 90-degree angle at every single corner. So I could look at this slope. This slope here is undefined. Okay, remember, undefined or a vertical slope will be perpendicular with a 0 slope, which would be horizontal. Okay, so vertical and horizontal are perpendicular to each other. That's not a horizontal line. Okay, so what we have here is not a rectangle because those are not right angles. Next question, is it a parallelogram? Well, you can't just say, well, it looks like it would be, right? What is a parallelogram? Well, remember, one way we can prove you have a parallelogram is the definition of a parallelogram. 2 sets of opposite sides are parallel. Well, obviously, these opposite sides are parallel because they both have the slope of undefined. So let's look at the slope of the other 2 sides. So let's go rise 1, 2, 3, run 1, 2, 3. Whoop. Let's rise 1, 2, 3, 4, run 1, 2, 3, 4, 5. So rise 4, run 5, okay? So this side has a slope, okay? Slope of 4/5. Okay? How about this side right here? So we can rise, I'll start at this one. We'll rise 1, 2, 3, 4 down, run 1, 2, 3, 4, 5 across, okay? So this is down 4 and left 5. -4 over -5 gives me a slope of positive 4/5. So what does that tell me? Well, that tells me that these 2 sides are parallel, which gives me a parallelogram. Okay? If it had said rhombus, we'd have to use distance formula, or at least use the Pythagorean theorem, like we did with the culminating activity, where we do 5 squared plus 4 squared, and we find out that this side was the square root of, 5 squared is 25, plus 4 squared is 16, so it's be the square root of 41. Then you'd find this is the square root of 41. You could do the same thing with these, except this one here, you just have to count, right? But it didn't ask us for a rhombus, it asked us for a parallelogram. Parallelogram, the parallel sides give it to us. 2 sets of parallel sides, parallelogram. Finding the coordinates of a point to make a parallelogram. All right, so in order for this to be a parallelogram, the 4th point has got to be down here somewhere, right? But where exactly is it going to be? Well, remember that opposite sides have to be parallel and congruent. So if I'm looking for, let's say, this side here, the opposite side is going to have the same rise and the same run. Okay? It has to, because not only will they have the same slope with the rise over run, but also they have to have the same distance, okay, because they have to be congruent. So what would the rise and the run be for this side here? Well, from this point to this point, if I'm thinking about the rise, that's up and down, that's y coordinates. So the change in the y coordinates from 0 to -6, we went down 6. And then for the x coordinates, going left to right, from -5 to -2. Well, that went, well, you added 3, so we went right 3. So guess what we're going to do for that point? We started here, and we went down and to the right. So for the opposite side, we're going to start here, and we're going to go down and to the right. So down 6, again, down is a y coordinate. So down 6 from -3. So -3 subtract 6, you're going to go down -9. You're going to go down to -9. What about the x? The x coordinate says we're going to the right 3 places. So we're going to go right 3. So we're going to take 4, add 3, and that's 7. So that means that my final point is going to be at 7 for my x, -9 for my y. So 7, -9 should be right about in here. And that is the answer we're looking for, 7, -9. Okay. So now we have 2 parallel and congruent sides, which by definition will give you a parallelogram. Okay, next question. Again, this is a parallelogram. They're telling us it's a parallelogram. We're going to have to find the coordinates of L. So we need the x coordinate and we need the y coordinate. The y coordinate should be simple. You know why? Because this y right here, the y's are shared. Okay? M and L have the same y coordinate because they are horizontally on the same line segment. So what is the y coordinate for M? Little r. So I know that my y coordinate for L must be little r. Well, what about the x coordinate? Okay. The x coordinate is not at n and it's not at k. Well, watch this. We get to k and we got to go back a certain amount. Well, because opposite sides are congruent and parallel, that certain amount will be this amount right here. So from point N, which is 0, 0, back to the same x coordinate as point M, okay, that's -q for the x coordinate right there, which means that they must have gone left q units to get to that point that we're talking about. Okay, going to go left q units. Well, that means that this right here must also be q units. Okay. So how do we go from this point with the x coordinate back to this point with the x coordinate? Well, this is S, and we got to go left q units. So simply, it's S take away q. So the answer for this question is you take s minus q for your x coordinate and r for your y coordinate. Should do it. Okay. Let's continue. Consider this quadrilateral. They give us the picture, they give us the coordinates. Now they say, let's find the length of JM and then the length of KL. So the length of JM. You could do this with the distance formula, okay? You absolutely could do this with the distance formula, with your J and your M. As a matter of fact, let's use the distance formula for the JM side, and then we'll use something else for the KL side, just to show you two different ways to do this. So distance formula is square root of x2 minus x1. So if it's J and M, let's call this x1 and y1, and M is going to be x2, y2. Okay, so that would give me -5 minus -3 squared plus -1 minus -4 squared. Okay, -5 minus -3 is -2, squared is 4, plus -1 minus -4 is 3, squared is 9. So we got the square root of 13 for JM. I'll put it up here, square root of 13 for JM. Okay, that's the length of JM. Now it says, what is the length of KL? Well, KL is opposite of JM, so it should have the same length, should have the same distance between them, right? If it's a parallelogram. If it's not a parallelogram, they won't be the same. So instead of the distance formula, let's do what we did in the culminating activity from Unit 1. Let's do the Pythagorean Theorem. I'm going to, for KL, I'm going to make a little horizontal segment and a little vertical segment to give me a right triangle, so that we have, let's see, 1, 2, 3 units up, and we have 1, 2 units over. So for LK, I know that 2 squared plus 3 squared equals LK squared. Now, if you felt really comfortable with the distance formula we did for JM, use the distance formula, okay? There's no harm in that. If it's graphed like this, I just wanted to show you that this is an option. If you want to use the Pythagorean Theorem, it's always an option right here, okay? So let's see. Say we got 2 squared is 4 plus 3 squared is 9 again. So 9 equals LK squared. We got to take square root. So LK is, let's not do that. It's not 9 at all, is it? Silly goose. 4 plus 9 is 13. So LK squared equals 4 plus 9, which is 13. Now we take the square root of both sides. We get LK is equal to the square root of 13. So we got square root of 13 right there. All right, so we have now proven that we have a pair of opposite sides that are congruent. Well, that's pretty cool. So what are we going to do? What are we going to do with those babies now? Well, let's find the slope of JM and the slope of KL. Right? So the slope should be pretty quick. You can either use the slope formula or you can use the picture and rise over run. Well, let's do one of each. Slope formula for Jm, okay, since slope is y2 minus y1 over x2 minus x1. y2 minus y1, x2 minus x1. We still have the x1s and the y1s and the x2s and the y2s from the distance formula. So let's go ahead and do this. So -1 minus -4 over -5 minus -3. -1 subtract -4 is 3. -5 minus -3 is -2. Okay, so the slope of Jm is -3 over 2. For KL, we used the Pythagorean Theorem before. So let's do the rise over run. Okay? So we would rise 3, we would run 2, and it's going down to the right. It's falling to the right, so it's a negative slope. So you could quickly just look at this one and say the slope is -3/2. Okay, so now let's look at C. The quadrilateral is a parallelogram because it has one pair of opposite sides that are congruent, even though those sides are not parallel. Well, if they have the same slope, they are parallel. So that's not it. Second choice, the quadrilateral is a parallelogram because it has one pair of opposite sides that are both congruent, root 13, and parallel, -3/2. That's a winner right there. Let's just read the other ones here. The quadrilateral is a parallelogram because it has one pair of opposite sides that are parallel, even though those sides are not congruent. Well, they were congruent. And then the quadrilateral is not a parallelogram. It is a parallelogram because one set of opposite sides that are both parallel and congruent, that gives you a parallelogram. And the last one, it says it cannot be determined whether it's a quadrilateral that is a parallelogram or not. It can be determined. We just determined it. Okay, so there's the answer for that one. Let's take a look at classifying parallelograms. Okay, so that last one, they didn't tell us it was a parallelogram. We had to prove it. So for this one, once again, they graph and they give us coordinates. Very nice of them. Right, let's see what they want us to do here. They want to have us find the slope of KL. All right, so KL, if you want to use slope formula, fine. If you want to do rise and run, that's okay too. Let's go over the slope formula, okay? So slope formula is y2 minus y1 over x2 minus x1. So for KL, let's call this x1, y1 for K, and x2, y2 for L. So that tells me my slope is going to be -2 minus -5 over 3 minus -5. Okay, so for KL, -2 minus -5 is 3. 3 minus -5 is 8. So my slope is 3/8. Now, if you said I'm going to rise 3, run 8, and it's going up to the right, it's rising to the right, I would buy that. Okay, that would be a good way to do it too. Now it says the slope of a side that's adjacent to KL. So adjacent to KL just means it's not opposite. That's the main thing. Adjacent is not opposite. Okay, so here's the opposite side. So it can be either one of the other two sides. We could find JK or ML. They should be the same slope because it is a parallelogram. Opposite sides are parallel. So let's find the slope of KL. All right, let's go from Oh, we already did KL. Let's do ML. Let's do this guy, right? So the slope of ML, we could rise and run, or we could do the slope formula. Yeah, we're doing the slope formula pretty nicely. Let's do the slope formula. So for ML, we're going to use L, and then let's call the MX1, Y1 for our slope formula. We're going to forget this guy because we've already used them. Okay. As a matter of fact, let's erase him. Cool. So Y2 minus Y1 is going to be -2 minus 6 over x2 minus x1, which is 3 minus 6. -2 minus 6 is -8. 3 minus 6 is -3. Oh, I'm glad they gave us this because this is a tricky one. My hint for you is to always simplify your fraction. Okay? Always simplify your fractions. Negative over negative is positive. Okay. So that tells me that these are reciprocals, but they're not opposites. Okay, they're not opposite. They're both positive. Okay, so now let's say we want to find the length of KL. The length of KL, well, distance formula, as we've already mentioned, x2 minus x1 squared plus y2 minus y1, that's a 1 squared. Okay, so we can do distance formula, or we can do the whole rise over run with the Pythagorean theorem. Okay. For KL, let's find the length using the distance formula. Okay. So KL, square root. All right. So back to KL. We're going to ignore these guys here. This is going to be x1, y1, okay, x2, y2. So let's go right to it. KL, x2 minus x1 squared, so 3 subtract -5 squared plus -2 minus -5 squared. Okay, 3 minus -5 is 8. 8 squared is 64. -2 minus -5 is 3. Squared is 9. So the length is the square root of 73. Length of a side adjacent to KL. Well, let's do LM again. Okay, so for LM, call MX1, Y1. Okay, let's do that. So we've got 3 minus 6 squared plus -2 minus 6 squared. 3 minus 6 is -3. Square it, you get 9. -2 minus 6 is -8. Squared, you get 64. Well, look at that. All right. So based on this information, let's answer the questions here. We already knew it was a parallelogram. Okay, we knew it was a parallelogram. So JKLM is a rectangle. For a rectangle, it needs 90-degree angles. Okay, is this a rectangle? Don't just look at it and say, oh yeah, those aren't 90-degree angles. Remember, perpendicular slopes are opposite reciprocals. Okay, we found this slope and this slope. We found that we had 3/8 and 8/3. Now, yeah, you can see that's not a right angle. That's not a right angle. You can see that. But the fact that these are not opposite reciprocals, if this were a -3/8, then sure, we would have had opposite reciprocals and we would have had 90-degree angle, which would then tell me it's a rectangle. But it's not a rectangle because that's not a right angle. Rhombus, this was the tricky one because a rhombus has got 4 congruent sides. Right now, we found that this side is √73, and we found that this side is √73. Since it's a parallelogram, we know that opposite sides are congruent. So yeah, this is rhombus. Now, is it a square? Well, if we had said yes to the rectangle for the 90-degree angles and yes to the rhombus for the 4 congruent sides, then we would also say yes to the square. Okay? But since we didn't say yes to the rectangle, it's not a square. And then we said it is one of them, so the whole none of these, it's not that. Okay, let's move on. Okay. I believe, is this the last one? It is. That's great. Okay, give coordinates for point S. Okay, point S is going to be down here somewhere. So that quadrilateral PQRS will be congruent to JKLM. Okay, and you're allowed to draw on the grid online. That doesn't mean you should take a marker and like mark up your computer screen. That means that Alex has little drawing tools. Hopefully you knew that. It's honors geometry. I'm sure you knew that. Okay, so what are we going to do? What are we going to do? Well, a couple things that you need to know. Remember when we did CPCTC, when we said, if I have something like this, then AB was congruent to DE and BC was congruent to EF. Well, anytime you have a congruence statement about polygons, it's always got to be true. The corresponding parts are congruent. So PQ has to be congruent to JK. And QR is going to be congruent to KL. And since we don't have S, we really want to know about S. So SR is going to be congruent to LM. So how I go from L to M will be the same strategy to go from R to S. So how do you go from L to M? Well, L to M, you're going to go 2 units and 2 units. I would say 2 left and 2 down, and that's going to be, cut and dry. But you can see that since, for example, P is going to be an angle that's congruent to J, they've rotated. They have rotated, maybe they have reflected, maybe they flipped it a little bit. So the two quadrilaterals are congruent, but that doesn't mean that, you have, here's a rectangle, okay? I can still turn it. I can still flip it, right? And it's the same size. It hasn't changed size, but when you rotate it or you flip it or you slide it left, right, all of those different translations or transformations, by the way, that's what Unit 6 is going to be about. All of those things, they don't make it not congruent to itself. Okay? So I know that from R to S, I'm going to have to go, same as L to M, I'm going to have to go 2 units one way and 2 units another way. So is it going to be 2 units left and 2 units down? No, that doesn't look very good. Is it going to be 2 units up and 2 units left? No, that's not going to do it. I think it's pretty obvious. I'm not going to mess around with it anymore. We're going to go 2 units down, 2 units to the right, And that right there, I hope, is going to be my point S. So now PQRS is going to be congruent to JKLM. And if you want to check it out, let's see. So that means PS, first and the last letter, going to correspond to and be congruent to JM. So JM is this guy right here. And PS is this guy right here. Do I know if they're congruent? Well, J, I go up 1, 2, 3, 4, and then left 1, 2, 3. So I go up 4 and left 3. Okay? And then from P to S, 1, 2, 3, 1, 2, 3, 4. So yeah, I go up 3 and over 4, which would mean that if you're going to do the Pythagorean theorem again, 9 plus 16 is 25, and the square root of 25 is 5. So yeah, we can actually say that JM and SP are both 5 units long. You don't need that last part. That's just me trying to prove that what we just did is correct. All right. So when you put it on the grid, that's where it's going to be. Okay, right there. And it doesn't ask you to name the coordinates, but you obviously could if you just count them. I mean, it's what, 4, -8? If they asked you for it, but they didn't. Okay. All right, that concludes day 3. That concludes unit 4. That concludes semester 1. Okay, it's been fun. See ya.